So, permittivity is a measure of how well materials store energy. Okay? So, if you want to explain it in a large way, it's how well materials can polarize itself. How well material can polarize itself. So, polarizing just means if before charges are kind of messed up, they're kind of all over the place, there's no real rhyme or reason to why they're behaving the way they are, and a electric field is applied, it kind of goes from that to this really quick. Yeah? So if it's got very high permittivity, it can polarize itself really, really well. So the higher the permittivity, the better it can store this energy. So usually the equation for this is relative permittivity times the permittivity of free space. So the permittivity of free space is 8 times 8.85 times 10 to the negative 12 coulombs squared over Newton meters squared. But this is a constant. This is not going to change. It's the permittivity of free space. And it is usually given in most tests. Now, relative permittivity is based on the material that you have. So for air, that's 1. So you would just go 1 times that number and you have the overall permittivity. If you had water or something that would have something like 2.6, you would just go 2.6 times this value is going to be put into that equation there. Yeah, dandy. So the one to watch out for is this one because it's going to get different between different materials. So, for example, positive charge with 3 times 10 to the negative 6 coulombs, that's the charge for it, so that's Q1, yeah, is 12 centimeters away from a different charge, a negative charge, containing negative 1.7 times 10 to the negative 6 coulombs. This is Q2, and they are 12 centimeters away. First things first, draw down how this would look like. Positive charge, negative charge, 12 centimeters away. Now, in the equation, what you need to use is meters. So 12 centimeters is just 0.12 meters. Yes? Okay. We're trying to find the magnitude and the direction. Q1 times Q2 must be positive over r squared times 1 over 4 pi permittivity. This is in free space, this is in air, so this is just going to equal exactly that value. This is going to give us the magnitude. So we're going to go if is equal to, how much is this value? That's charge 1, yeah? 3 times 10 to the negative 6 times that value, Q2, negative 1.7 times 10 to the negative 6. Now important, whatever value we get is going to have to be positive. Yeah, these are the guards of the doors. They don't let any negative vibes get out there. So whatever value we get from multiplying these two, even if it's a negative, you gotta switch it into positive. Divided by 0.12, because that is the distance, squared, because that's in the equation, times 1 over 4 pi, and this is our constant value, so it's not gonna change, is it? No, because it is in free space and in air. Yeah, so this will be our force. So the force is going to equal 3.18 newtons. That means that this charge, number 1, so this one is being attracted this way. This one is being attracted this way. From left to right, what's the usual sign on the charge? As we discussed, from left to right, it's a positive direction. From right to left, it's a negative direction. So, this one, charge 1, force of charge 1 is going to go positive 3.18. Force of charge 2 is going to go negative 3.18 newtons. They're both exerting the same amount of force on each other, but they're doing it in opposite directions. And that's it.